Hello, am I audible and is my screen visible? Please let me know.
Yes, it is visible and audible.
Okay, thank you. Good evening, everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. So, this is an extra session for this course, and today we will discuss some practice problems on which will cover all the topics. So, throughout this course, whatever has been taught, some few 8-9 practice problems we will solve in this session. And if you have any questions, you can ask me during this session. Okay, we will start solving some practice problems. So this is question 1. Suppose we want to add a regularizer to the linear regression loss function. To control the magnitudes of the weights beta, we have a choice between omega 1, which is absolute summation of absolute values of beta, and omega 2, which is summation of squared values of beta. Beta are the set of weights. Beta is the set of weights, and which one is more likely to result in sparse weights for the linear
Omega
regression?
1. Omega 1 because that is lasso regression.
Okay. So you can write your answers in the chat. So correct answer for this question is option A, omega 1. So this is omega 1 is called lasso regression. The regression that uses this regularizer is called lasso regression, and omega 2 is called ridge regression. So this lasso is more likely to produce sparse weight, so most of the weight parameters would go down to 0. But in case of ridge regression, it is observed that the values of these weights will be reduced to close to 0, but not exactly 0. So most of the betas will not come down to 0. Most of them are very small values, but lasso actually drive those values to 0 for many of the parameters, and it would also work as a feature selection method. For those features whose weight values go down to 0, those features are not required for classification or regression task. So it also works as a feature selection. Now question 2. Which of the following statements are true? The chances of overfitting decreases with increasing the number of hidden nodes and increasing the number of hidden layers. Option B. A neural network with one hidden layer can represent any Boolean function given sufficient number of hidden units and appropriate activation functions. Option C. Two hidden layer neural networks can represent any continuous function within a tolerance as long as the number of hidden layers is sufficient and appropriate activation functions used. So more than one option can be correct for this question.
Is it B and C?
Okay, let's see what others say. Manas Arora says AC. Pentas Ravani says B. Ritika Kesri says BC. Okay. Anyone else? Any other answers? The correct answers are B and C. The first option is the chances of overfitting decreases with increasing the number of hidden nodes and increasing the number of hidden layers in a neural network. So this is certainly not right. If you increase the number of nodes or increase the number of hidden layers in a neural network, so the complexity of the neural network model increases, and if the complexity increases, it becomes much more prone to overfitting. So chances of overfitting increases with that. So that's why option A is not correct. Option B says a neural network with one hidden layer can represent any Boolean function given sufficient number of hidden units and appropriate activation functions. This is correct. So a neural network even with only one hidden layer, it can represent any Boolean function, like XOR function is one of the most difficult ones which can be modeled using a neural network with only one hidden layer. So any other Boolean function can be modeled with only one hidden layer, and if we have sufficient number of hidden units, then only one hidden layer will be sufficient for that. And option C says two hidden layer neural networks can represent any continuous function as long as the number of hidden units is sufficient and appropriate activation function suit. This is also correct. So if we have two hidden layers, then it's much more powerful, and if we can add as many hidden units as we want, then we don't need to add more hidden layers. With two hidden layers would also be sufficient to model any continuous function.
This XOR function cannot be modeled by one of these neural networks, no? Which one is that? XOR function cannot be modeled.
XOR cannot be modeled without hidden layers. If you don't have any hidden layer, then it simply becomes like a logistic regression.
Okay.
So in that case it would not, but if you add one hidden layer, after that it can do that.
Okay, so this perceptron does not have hidden layers,
Yes,
right?
yes, perceptron, logistic regression, these methods do not have any hidden layers, so they cannot classify XOR function. But
okay.
Question 3. For the given confusion matrix, compute the recall. So this true positive and true negative, these are actual, it can also be written as actual positive and actual negative. So you have to compute the recall from this confusion matrix. Ajay Chauhan says option C. Okay. Harapriya Kaur says option C. Ritika Kesri says option C. Penta Shravani says option C. Priyanka Sundar says option C. Ans Arora says D. PG Satish says D. Okay, so many of you are saying C, some of you are also saying D. Lakshmi says D. Dhanasri Raut says C. So the definition of recall is true positive divided by true positive plus false negatives. So we have to identify what is the true positive for this confusion matrix and what is the false negative. So true positive means it is actually positive and also predicted as positive. So that is this 6. And what is true negative? So false negative is it is falsely classified as negative. That means it is not actually negative but predicted as negative. So that is actually positive but predicted as negative. So at the 3 is the value for Fn. So 6 divided by 6 plus 3, 6 divided by 9, which is 0.67. So false negative, I think many of you have computed this false negative value wrongly. That's why most of you have written option C. So false negative is it is not negative but predicted as negative. So that is this 3. That those data points were actually positive but predicted as negative. So there are 3 such elements. So Fn is 3 here. So 6 divided by 6 plus 3, which is 6 by 9, 0.67. Is this understandable?
Yes, yes.
So option D is the correct answer here. So question 4. The figure below shows a Bayesian network with 9 variables, all of which are binary variables, so that doesn't really matter whether it's binary or not. So which of the following is or are always true for the above binary Bayesian network? So basically you have to find out conditional dependencies given some variable or not given any variable. So option A says probability of A comma B given G is probability of A given G into probability of B given G. Option B says probability of A comma I is probability of A into probability of I. Option C says probability of B comma H given E and G is equal to B given E and G, H given E and G. And last option is probability of C given B and F equals probability of C given F. Pen test Ravani says option B. Ajay Chauhan says option B. Was that question discussed previously? Otherwise it cannot be solved so quickly.
It is already discussed now.
It might be in some other live session. Yeah, I didn't discuss in my live session. Okay, yeah, that might happen. Okay. Because those who haven't solved this question previously, they can try to solve this. So for this question you have to check for every option whether it is true or not based on this Bayesian network. First option says that probability of A comma B given G is probability of A given G into B given G. That basically means whether A and B are independent or not given G. It says that A and B are independent given G, so you have to check whether it's true or not. So A is here and B is here and here is G. So if G is given, so if C is a common child of these two parents A and B, so if C or any of its descendants is given, in that case this path is not blocked. So A, C, B, this path from A to B is not blocked because G is given. So that means A and B cannot be independent of each other, there exists a path from A to B. So that's the option, and that is the only possible. Also the another path, this path is also blocked because of G. Sorry, this there exists at least one path, so you don't have to check for other paths. So this one is certainly wrong. Then the second option, probability of A comma I equals probability of A into probability of I. So with it says that A and I are independent of each other. A and I, these two nodes are independent of each other, so no evidence is given, no variable is given here. So if no variable is given, so this is the path, this is the path, there is another path, this one. So for both the path we can see that if G is not given, so G blocks this path, G blocks here, blocks this path. And also for this path from A, C, B, E, F, H, I, for this path C blocks this path because C is not given. C is a common child of A and B, so if C is not given, it would block that path. If C was given, it would not block that path. So C blocks this second path and G blocks the first path. So both the paths are blocked between A and I.
It's C, because C is not given, it blocks the path, is it?
Yes. So in case of common child case, so there are three cases in D separations. This is the common child case. C is the common child of AB. So
Okay.
if in this case, in case of common child, if the common child or any of its descendant is given, then it does not block, and if it is not given, then it blocks.
Okay.
For the other
So-
two cases of D separation, if that variable is given, then it would block. But in case of common child, it is exactly the opposite of the other two cases.
Okay, so here it is not given, so it blocks.
Yeah, C is not given, so C is blocking that second path, and G is not given, so it is blocking the first path. In both the cases, so C is a common child of AB and G is a common child of D and F. So in both the cases, the common child case is being applied, and both the paths are getting blocked because of two different variables C and G. So both the paths are blocked, so no path exists between A and I. So A and I are independent, as there is no single path exists between A and I. So A and I are independent of each other. So this is correct, option B. Option C says that B and H are independent given E and G. So B and H are independent given E and G. So this path, there are two paths from B to H. This is the first path. So E is given, so E blocks this path here. This is a simple path, so it is getting blocked by E. We have to check the second path, which is this one, B, C, D, G, F, H. So this path, and G is given. So if G is given, G is again the common child of D and F. So G is given, then it does not block this path here. And if G does not block, no other variables are blocking here. So this path is not blocked. So this B, C, D, G, F, H, this path is not blocked between B and H. So there exists a path between B and H. So it will these two variables cannot be independent of each other. So the first path was blocked by E, but the second path is not blocked because G is given. If G was not given, then it would have been blocked.
So E is also given, no? So it is also blocking. First path.
So yeah, first path is blocked, second path is not blocked. First path is blocked here because of E.
Because E is
E is
given.
given. But for the second path, the longer path, B, C, D, G, F, H, this path is not blocked because G is given, isn't it? G is the common child.
Now, one case you are saying if E is given, so it is not blocked.
So there are
If-
three rules in deseparation. If it is a series connection, the first case is a series connection, right? B to E, E to F, F to H. These are the arrows here, right?
okay. We have to see the arrow.
This, yeah, the arrow shows you the direction of the relations. So there are three deseparation rules. There are for three different kinds of relations or directions of arrows. So E is blocking this path, but G is the common child of D and F. Common child because the G has incoming edges from both D and F. So G is a common child. In case of common child, if the common child is given, then it does not block.
Okay.
But in case of E, that is completely different. E is given, that's why it blocks this first path. So you can go through the deseparations rule.
Understood.
Yeah. And
There are three cases. One is series, second is common child, and what is the third case for the deseparation?
third one is common parent. So this node would be parent of two other nodes. So the arrows in two different opposite directions.
There also, if
That is same as the series connection.
Okay, parent is known. That means
If this is given, it blocks this path.
Okay.
And also for the series connection, if it is given, it blocks this path. So only the exception is the third case, which is this common child case.
Okay.
And the fourth option says that
Sir, one more thing.
Yes.
If one direction is given from G to H, then also it will be it will be independent. I think
G to H,
G to H.
like this.
Yes.
If G to H is given, in that case this path
It will be same
gets
as the
blocked.
first path.
Yeah, in that case this so again B, C, D, G, H, this would become one more path between B and H, right?
Okay.
So that path
also-
gets blocked because of G. But the other path that goes via F, G, F, H, that path is not blocked.
We have to check which is there any path is not
If
blocked
there
or
is,
not.
yeah, you have to check all the paths. If you find at least one path that is not blocked, then those two nodes cannot be independent. All the paths have to be blocked to become conditionally independent of each other. There exists at least one path which is B, C, D, G, F, H. This path exists, so these two nodes cannot be independent of each other. And the fourth option says that C is independent of B given F. So C and B given F, this is much easier. So we can already see there exists one direct edge from B to C. Hello, am I audible? Hello, am I audible? Hello, am I audible? Hello.
Yes.
Yeah, I lost.
Yes.
Yeah, I lost
Yes.
my internet connection for a while. And is my screen visible properly?
Yes, visible.
Yeah.
No, no.
Is it visible now?
Yes. No.
Yes.
Yeah, so for the fourth option, it says that C is independent of B given if. This is much easier option because there already exists an edge from B to C, direct edge from B to C. So certainly B and C are there exists a path between B and C. This direct edge is there from B to C. So these two nodes cannot be independent of each other, whether F is given or not. So this is not right. So only correct option is option B. And moving on to question 5. For the given graphical model, what is the optimal variable elimination order when trying to calculate probability of capital E equals some small e? Pintas Ravani says option A, Ajay Chauhan says A, Ritika Kesri says A. Harapriya Kaur says A, Dhanasri Raut says A. Okay. Yeah, so the correct answer is option A. So all of you have written the correct answer. So the variable elimination order depends on the dependencies or the relations between the variables. So A is not dependent on any other variables. There is no incoming edge from A. So first A can be eliminated easily. Then once A is eliminated, now B can be eliminated. Then C, then D, and finally we will get the value of E. And this can also be represented mathematically. So this is the joint distribution, probability of A, comma B, comma C, comma D, comma E, and to get the value of probability of E, we have to sum this joint distribution up over all the other variables. And first we have to eliminate A, then B, then C, then D, like this. So option A is the correct answer.
Actually, what do you mean by variable elimination? What is that?
So if you try to compute probability of capital E equals some value of small e is some actual real value for the variable capital E. If you want to compute that, you have to eliminate the other variables from this joint distribution. You will be given this joint distribution, is probability of A, B, C, D, E. Now you have to if you have to compute only for one probability of one variable for some specific value, then you have to eliminate the other variables. So that elimination order should be based on the directions. Here the directions are much simpler. So in only one direction the variables are connected, but in a Bayesian network the connections can be very random. So in that case you have to eliminate those variables in order of their dependencies. Question 6. The data points shown in the figure below have two features, x1 and x2, and each data point belongs to one of the two classes shown in the figure by cross and circle. if you have to select one feature to use in a classification problem, which feature will you choose? So these are the two features, x1 and x2. If you have to choose only one feature in a classification problem for this dataset, which feature will you choose? x1, x2, any one of the above, or none of the above are suitable? Ajay Chauhan says option C. Okay. Saisab Shah says option B. Ritika Kesri says option B. Harapriya Kar says option D. Okay. Parambrata Ghosh says option C. VG Satish says option C. Vijit Shah says option C. The correct answer is option B, x2. So if you observe this figure, you can see that the data points are mostly spread out along x2 axis, and this will be a very simple decision boundary for these two classes, and that is this decision boundary is simply dependent on x2. The equation would be something like x2 equals some constant a. This is the equation of this straight line. It doesn't really need to have the values of x1, because with values of x2 only we can segregate these two classes easily. But if we choose x1, we cannot do that. Along x1 the data points are very much cramped, so along the direction of x1 the data points are not spread out that much, and they are overlapping, but along x2 axis they are not overlapping at all. The classes are not overlapping at all, and if we choose only x2 we can separate these two classes easily. So x2 would be the correct answer. Using x2 only we can classify the two classes without having x1.
If the data are given in the top and bottom, suppose processor on the top and circles on the bottom, then the answer will be x2, x1.
Yes, so you have to in that case it would become x1. You have to see whether with only the values of x2 I can separate these two classes or not, and in the other case that you mentioned, you have to you can check that with only values of x1 you can separate those two classes easily.
And if it is mixed, so none of this will be true.
Yeah, if the classes are overlapping, here the classes are not overlapping at all, but if the classes are overlapping, then it might not be the case. In that case, then you need both the features, or even if the data points were like this, so this would become the decision boundary. So not as by taking only x1 or x2 you cannot do that, because this straight line decision boundary is dependent on both x1 and x2, isn't it?
Voice breaking.
Hello?
Okay.
Yeah, am I audible properly now?
Voice is breaking little.
Hello? Hello?
Yes.
Now it is.
You are audible.
Okay. So for this figure with only x2 we can do, but for other cases it might not be the case. Yeah. Now question 7. Suppose we are given the following data where x and y are two input variables and class is given here. So these are the two features, x and y are two features here, and class is the class variable or the output variable. And suppose you want to predict the class of a new data point x1 comma y1 using Euclidean distance in 3nn. So this is knn with k equals 3. In which class will the new data point belong to? The new data point is 1 comma 1, x equals 1, y equals 1, and you have to use 3nn to compute the class of the new data point. Ajay Chauhan says option A. Okay. This question will take a lot of time for computation, so I will show the only the method how to do that. So these are the training data points, and the new data point is x1, x equals 1, y equals 1. So for this new data point you have to compute the distance from this new data point to every other point in this data set. So you have to compute 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 distance values from the new data point, and then you have to you have to compute the Euclidean distance, and then you have to see which are the 3 closest points for this new data point 1 comma 1, and from the 3 nearest points the majority class would be the class of the new data point. So for example, for the first training data, the new data point is 1 comma 1, and this first data point is minus 1 comma 1, this one, the first data point is minus 1 comma 1. So the distance, Euclidean distance, would be 1 minus 1 whole square plus 1 minus 1 square. Square root of that, square root is not really required for this, because you just have to check the closest 3 points, so squared distance would also work for this case. So it would become 2 square, which is 4. So square of the Euclidean distance is 4 for the first data point. Then you have to do the same thing for the second data point. Second data point is 0 comma 1. So again the square distance would be 1 minus 0 whole square plus 1 minus 1 square, so it would be 1. So similarly you have to do the same calculation for the other 6 points, so total 8 points, and then you have to check which are the 3 closest points, and the majority class of that of those 3 closest points would be the class of the new data point. And if you compute this, you will get that option A, positive class, is the correct answer. So is it understandable?
Yes.
Okay. Question 8. Consider the following image showing data points belonging to 3 different clusters. I hope it is visible. Different colors are there, red, green, and this one is blue. this ring is blue. Which among the following clustering algorithms will perform well in accurately clustering the given data points? K-means, single link hierarchical, complete link hierarchical, and DB scan.
DB scan.
Okay. Harapriya Kaur says D, Shashab Shah says D, Ritika Kesri says D, Ayappa Swami Burra says D, Vijay Satish says D, Pentas Ravani says B, C, D. Okay. So the correct answer is option D. So most of you have written correct answer in the chat. So K-means would certainly not work. K-means would not be able to find this cluster. K-means would be able to find these circular or spherical clusters, but this ring like cluster K-means will not be able to find out. And single link hierarchical and complete link hierarchical, the same problem would happen. So in case of single link, it would, as it marges closest clusters, so at some point it would merge these two clusters. It would merge these two clusters into one, because these two clusters would be very close to each other. So it would merge these two clusters. Same thing would happen on the other side. This one and this, these two might be merged into one cluster. And same would happen with complete link clustering, that it would merge the closest two clusters. Only difference in single link and complete link is the computation of the distance. Otherwise closest clusters would always be merged. And but that problem doesn't occur in DB scan, because DB scan is density based clustering. So it would observe that the density of these points are higher for this ring, so it would form this ring like cluster, and these clusters are easy to find for any algorithms, so it would be able to find the other two. So DB scan would be the correct answer, because this these clusters are generally density based, so the density based algorithm will be a perfect choice for this.
Here single link hierarchical and complete link hierarchical algorithms would work almost the same way in this case.
Yeah, in both the cases it would, I mean the algorithms are different, but in both the cases it would merge the closest clusters. So it would, at some point it might merge these two clusters, but these two clusters should not be merged. But we can see that these points and these points in these two clusters are very close to each other.
Yes, understood, got it.
Yeah, DB scan is the correct answer here. So these were the practice problems that I wanted to discuss in this live session, and if you have any other questions you can ask.
In the assignment questions, week 1, question number 5, can you just take it?
Week 1, question number 5.
Consider a linear regression model of the form y is equal to beta 0 plus beta 1 x1 plus beta
Yes.
2.
Yeah.
So over here, in the solutions, what they have said is to solve this, first to find the beta matrix
Yes.
by using x transpose x inverse x transpose y.
Yes.
It's a very long matrix, no? Because there are 6 rows and 3 columns. So
Yeah.
that's a very complex matrix. So is there any easier way to do it?
No, yeah, that matrix calculation you have to do x transpose x inverse x transpose y, so that would give you the beta matrix. Other than that, there is no other solution for this question. You have to compute that and then you will get beta, and you have to find the output of the new point.
Can you use this, it's the mean squared error, right? So can you use that h of x minus y the whole squared is equal to 0, and then minimize that? And
yes, that is gradient descent algorithm. I mean, again you have to do the iterative process for gradient descent. That is very much easy to implement in a computer, but you cannot do that iterative process manually. So it's better to do that matrix process. that is easier for computation. It would also be a very long computation because it would become the size of the matrix would be very big, but that is much easier than the gradient descent iterative algorithm.
Okay, next is question number 8. Take one. Question number 8. Consider a binary classification problem where they are doing certain measurements from a blood test and need to predict whether the patient does not have a particular disease or the patient has a disease, class 1. In this problem, false negative. Did you see the question?
Yeah, I can see that question.
So here, we have taken the row describes the true class and the column denotes the predicted class. So on the left side we will have true values and on the top we will have predicted values, correct? So in that case, should not option number B be the answer, because we are over there 100 would come for false negative, isn't it? Because row denotes actual values and column denotes predicted value.
Row denotes true class, column denotes predicted class. Okay, so first row is for class 0, second row is for class 1, actual values of 0 and 1, and in the column predicted values of 0 and 1.
So here we are utilizing a false negative, because if somebody has cancer and we are saying no, he's healthy, that should be given a very high penalty, isn't it?
Yes.
So that will be denoted by
false negatives means it is actually not negative but predicted as negative.
Yes, so that will come in the first row, second column, isn't it? Such a thing. False negative.
False negative. 1 minute. Rows denote the actual classes. So in the actual class, so here negative means class 0 or class 1 in this case. Class 1, yeah, it would. No, positive is class 1, negative is class 0.
Yeah, so I'm taking 0, 1, 0, 1 on both the things. So 0, 0 will be true positive and 0, 1 will be false.
1 minute, 1 minute. The actual 0, actual 1, this is predicted 0, predicted 1. So false negative means it is actually positive but predicted as negative. So this row, this would be false negative, isn't it?
Okay, no, 0 means disease free. 1 means
1 is disease. 1 is disease. It is written that disease free is 0, 1 is disease, and disease means so false. So in that case this row would be this cell would be the false negative, A1 P0. So that is the answer given here. So basically you have to find out which cell in the table it is actually the false negative is actually. So if you find it out, then it is easy.
Okay, fine. My next question is week 2. Can you just briefly explain what is this forward stage-wise, forward step-wise, backward stage-wise, backward step-wise?
During this session I also told that time that step-wise is basically in every step you want to include one feature to a subset if it increases the accuracy of your model or decreases the error of your model. So basically it improves the performance of your model, then you keep on adding one feature after the other greedily. And
what do you mean by greedily?
Greedily means in every step if the performance increases you add, otherwise you don't add. So that is greedy method. So forward, that is forward stepwise. Backward stepwise is you start with all the features and you keep on removing one feature after the other if the removal does not impact the performance of the model.
Okay.
Then you don't need to keep that feature. So every step you remove one feature if it does not impact the performance of the model, or if it impacts significantly, then you keep that feature. So that is backward stepwise.
Okay. And what is forward stage-wise?
Forward stage wise, yeah, I also have to remember that in every iteration, basically here it's called every stage, every feature, some correlation computation happens there, but I can't exactly remember the process. You can go through that video lecture, there it is explained properly. I can't exactly remember this actual process. So in every stage, whether you will include one feature or not, for that you compute some correlation. I don't exactly remember that. I think in every stage you have a certain number of features at some stage. Now if you want to include one more feature, then you compute the residual. Residual is basically the error whatever you have right now for that model, and if the correlation is high, then you include for something like that. I don't exactly remember, so it would be better if you go through that lecture, that part in the lecture.
Okay. Then week 2, question number 4, can you please see?
Yes.
How to solve?
Since squared error as loss function, of the following parameters would you use to model this function? We want to do this. So this is I think the values of a and b you have to find out.
Okay.
So basically for every option you check whether it gives you the least squared error or not. For 4 options you check what is the squared error for the 4 different values of a and b, and whichever gives you the least.
Actually, how to do that?
Squared error is actual value minus predicted value. Predicted value is ax plus b and actual value is the y column.
But
It is summation over fxi minus yi square over all the elements. Here there are 4 data points are there. So this you have to do this for 4 different values of a comma b. So the fx is axi plus b. So you do this for all the 4 different values that are given in the options, and whichever gives you the least squared error, that would become the value.
Okay.
Or otherwise, I mean, you can also do you can also run the algorithm for that, and then also you can find out a comma. But this is much easier way to do that. That for every option you check what is the squared error you are getting, and whichever gives you the least squared error, that will be the answer.
Then can ridge regression, is it true to say that ridge regression may reduce the number of variables?
Where is that question?
It's somewhere in week 2.
Ridge regression, I mean the question I also discussed today, that ridge regression can reduce the number of features, but it generally does not drive the value straight to 0. It becomes very small, the weight values become very small, but it does not become 0 exactly. But in case of lasso, it does not just reduces the values, it would reduce it to 0 completely. So for
So I'm referring to question number 6 in week 2. So there the answer is C, and C says that ridge regression may reduce the number.
Yeah, may reduce is correct, but it does not guarantee that it would reduce. May reduce is certainly correct. It can drive the value to 0, but for most of the variables it does not do that. So but it can do that. but lasso is much more likely to do that.
So the third assignment, question number 6, can you say? We have to find the values of beta 0, beta 1 and beta 2.
This one, I think in the solution PDF it should be given that for different beta values you compute the likelihood. Likelihood is simply product of all the probability values for all the data points. This pxi is given, so pxi is for xi point. Now you do that for all 4 points, and
Sir, that pxi for e to the power beta 0, beta 1 x plus beta 2 x, but we have the values of x1.
I think there might be some typing error, so I think it should be beta 0 plus beta 1 x1 plus beta 2 x2. I'm not sure, but I think this should be the actual expression. Otherwise it doesn't really make sense to have x into this equation. X doesn't mean anything. x1 and x2 are two features.
It is beta 0 plus beta 1 x1
Yes,
plus beta 2
yeah, that is what I am saying, that it should be beta 1 x1 plus beta 2 x2, and then you just take the product of the all 4 probability values, and whichever beta 0, beta 1, beta 2 value gives you the highest likelihood, that would be the answer.
Okay, sir. Thank you.
Sir, ये क्वेश्चन नंबर, हेलो,
Yes,
ये वीक 12 असाइनमेंट,
week 12. Yes,
क्वेश्चन नंबर 8.
question number 8.
हाँ,
Yes,
the solution provided, it is not matched with the answer.
solution in the solution PDF, what is given? Which
Solution, it is given in the solution. Can you allow me to show the screen?
No, there is no need to show your screen, but you are getting a different answer from whatever is given in the solution PDF.
Yes, there is a calculation mistake in the solution.
Okay, then you can post it in the discussion forum. They would re-evaluate it if there is actually some error, and they would also reply if your method is wrong. Otherwise they would change if your method is correct.
Same method. First is a 0.9 into 0.9, that is a 0.81. Then multiplied by 0.9, it is just given 0.72, but it will be 0.729. Further multiplied by 9.9, and in the solution it is given just only 0.63, and further multiplied by 0.9, it is given just 0.54. So as per complete calculation, the answer comes 0.59, but that option is not given in the option, so I marked 0. But in the solution, round off, after round off, it is given 0.54.
Okay, no, if there is any error, they might evaluate later. So you can post in the discussion forum. NPTEL team will check that, because if that is the correct,
The solution released on the assignment.
yeah, even if it is released, if there is something wrong, they might check. If there is nothing wrong, then they will not change, but you can ask in the discussion forum. They will also explain why they are giving this as the answer.
Similarly, I have posted the complete solution for assignment 10, which I discussed in the previous lecture.
That complete link, single link question.
Complete link clustering. So
Yes.
you can see this on the forum.
Yeah, I have seen your post there, I think, in the group. but I'm not sure about that answer. As far as I know, that for complete link also two clusters are merged if they're the closest, whether it's complete link or single link. So I'm not sure what exact method has been used there, but yeah, I've seen that.
Because
Sir,
in
for
the
that complete link problem, hello sir.
Yes.
For that complete link problem, that solution, whatever the solution is given by the team, can you tell the logic of that solution?
So
Because as for us, we are getting the answer D, and then telling
So
us D.
as
So can you tell the logic of that?
as far as I know, how to do the complete link hierarchical clustering. So while computing the distance between a pair of clusters, you will use complete link distance strategy, which is the two furthest points would give you the distance between the two clusters. So that would become the distance between the two clusters.
Euclidean distance or Manhattan distance?
If nothing is given, I think Euclidean distance.
As for that question, we are calculating by Euclidean distance, but as for their logic, what actually they are doing?
Yeah, that
Can you tell them?
that I don't know. I mean, generally, if nothing is written, certainly we use Euclidean distance between two points. So if Euclidean distance, whatever distance measure you are choosing, if the distance between the two furthest points would be the distance between the two clusters, and at every iteration two closest clusters are merged. So that is the algorithm for complete link clustering.
Okay.
Okay.
Sir, can you please go through that question 1 of this video lecture?
Which one?
Now you taken the question 1. Can you go through that?
Today's session.
Yes.
Question 1.
Yes, sir.
This one.
Okay, sir. Thank you, sir.
Okay. So if there are no other questions, then we can end this session here.
Sir,
Yes.
in week 7, 6th question, could you please go through that, sir?
6th question. Yes. In this,
I don't understand actually that how to do that.
we have a logistic regression that computes the probability px, that is that a given input x belongs to positive plus for a threshold theta, the class levels fx belongs to negative positive are predicted as given. For theta 0.1 we have tpr equals 0.8, fpr equals 0.3. Then which of the following statements are correct? So if you decrease the value of theta, then both true positive rate and false positive rate increases, I think. And if you increase the value of theta, then both tpr and fpr decreases, isn't it? I think that is right. Can anyone confirm? I think if we increase both TPR and FPR decreases, and if we decrease theta, then TPR FPR increases. I think so. Yeah, using that it has to be solved, I think.
So these values are fixed, sir? Like theta is equal to 0.4.
Yeah, so for 0.5 the TPR and FPR values are given. Now if I decrease or increase the value of theta, so 0.4 basically means we are decreasing the value of theta, and 0.6 means we are increasing value of theta. So based on that you have to answer.
Okay. Okay, sir. Thank you.
Sir, can you show me question number 5, sir?
Which assignment?
Now we have been presenting a slide. I missed it question number 5 alone, sir.
Okay. This one.
Yeah, sir.
So it was in 1 hour session. It is already past that 1 hour 15 minutes. So yeah, thank you everyone for joining. If you have no other questions, then we can end this live session now. Thank you everyone for joining.
Thank you, sir, for your very good answer.
Thank you.
Sir, will it be posted, sir?
Yeah,
This
this
video
video and slides would be uploaded, and you will get the links.
Okay, thank you.
Can we mail if you have any further doubts?
Hello.
Can we mail you in case we have any further doubts?
You can post in the discussion forum. There the
Oh,
live session TAs are also there, and the actual TAs are also there.
right. Okay.
Thank you everyone for joining.